mess about with the DR VDR thing again. That was just a nice little thing to show you guys. Let's go. That's not right. Let's go ahead into router OSPF 1, and we configure the network interface connected to router 1, which is there. And remember, area 1 this time. Let's go onto R1 and configure this side. Let's configure the router ID, just like we would. Now let's configure the network's ID, the network ID, sorry, that we want to bind it to. Area 1. So that's both sides. Let's just wait for this to come up now. Oh man, these take so long.
Stop whining!
I'm not whining, dude. I'm just tired. Oh man, this is taking forever.
Stop it!
Man, come on. Give me a break. Tell you what, let me just try and do a ping. Maybe this will wake it up. 100.1 at 12.2. That is up. So there we go. All right, so that's kind of shimmied it along a little bit. So now we've got a neighbor 1.1.1.1. The relationship is up. Let's just do a show IP OSPF neighbor. You can see the state. So router 2 is the DR. So in this case, we didn't actually tell the interface its OSPF priority, and router 2 is still worked out that it's the DR. The reason for that is when the OSPF adjacency starts to build, the router with the highest IP address wins the election for DR anyway. So that's the way that works. So when you've got a router with the same priority, the highest IP address wins the election and becomes the DR. So there we go. Right, so now R1 is up. Let's have a look at the routing table there. Show IP route. Let's see what we've got. So we've got R2's loopback interface, we've got R3's loopback interface, we've got the subnet between R2 and R3 there, and they all are IA. IA is inter-area, so extra area, I guess you would say. So remember, R1's in area 1, and R2 and R3 were in area 0. So anything we've learned from area 0 is an inter-area route, and O is OSPF. So that's nice. I'll tell you what we haven't done. We haven't put the loopback interface of R1 into this OSPF process. Let's put that in. There we go. So now on R3, hopefully R3 should have a route back to R1's loopback, which it does. There we go. So let's just do a little bit of test. Let's ping 1.1.101, and we can. Let's ping 3.3.3. And we can. That's great. Alright, so this is about stub. So we're going to configure area 1 as a stub. Let's go on to R2, because R2 is the ABR. ABR being area border router, and the area border is between area 1 and area 0. So R2 is going to be the ABR. So it's on the ABR that you configure the stubbiness. So we're already in the OSPF process here. The stub. So to configure the stub, easy peasy. You use the area command, area number. So area 1 is going to be the stub, and then you just give it the keyword stub, and that's it. So on the ABR now, we've configured area 1 to be a stub. So you see the adjacency drops. The adjacency to neighbor 1.1.1.1 has gone down. That's because area 2, sorry, the router 2 believes that area 1 is a stub area, but router 1 has still thinks it's an ordinary area, it's a normal area. So we need to go into R1 now and tell it, oh no, actually you're a stub area. Otherwise the adjacency won't ever agree. It's one of those things that it needs to have. So area 1 stub. Hopefully the adjacency should come back, which it does. So let's just remind ourselves of the routing table. This is what it used to look like. We had a route to 2, we had a route to 3, we had a route to 100.1.23.0, and they were all IA routes. Let's have a look at it now. Let's just do a show IP route. There we go. So I've still got a route to 2. Still got a route to 3. I've still got a route to the subnet between R2 and R3. But look, I've got a new route here. See this one? So this is the default. This is a default route 0000/0. that's been injected via router 2 to router 1. Huh. So the reason behind that is because Cisco say, well, not Cisco, but the RFC says for a stub area there's only one way in or out that network. There's only one way in or out. So why would you need all of these other routes? The 2 and the 3 all go through 12.2. Everyone's going through 12.2. So why do I need all these routes when there's only one way in or out? I might as well just have a default route and then forget all the others, and that's fair enough. But by default, when you set the stub type, it still allows the type 3s in, the type 3 summary routes in. Yeah, the type 1s and the type 2s are all stopped at the ABR, but the type 3 still comes through. So what do we do? What do we do about that? The way to override those routes coming in is to just put the no summary keyword on the end, and this will just stop the type 3s coming through. By the way, if you guys want a quick revision on the types on the website defaultroute.co.uk, there's an article about this. OSPF information CCIE candidates need to know. You guys just click on that and then go through the type list. It will tell you. So there's the type summary LSA, and it'll tell you all about that and how that works. Okay, so back on the router. So we've set the no summary type now. Notice the adjacency did not go up and down. That's because it's still a stub. It's just being told not to inject the summary routes anymore. Now let's have a look at the routing table on R1, and you see those other routes have gone. So I've just got the default route now. So can I still ping router 3? Yeah, sure I can. Can I ping router 3? From the loopback interface of 1.1.1.1? Yes, I can. So does router 3 know router 1's loopback address? Yes, it does. So what's this telling us? This is telling us that router 2 is stopping summary routes going into area 1, but it's allowing summary routes to come out from R1 to area 0. So R3's got that route there, which is great. So the whole principle around stub area is basically reducing the size of the routing table, because you know what, if there's only one way in or out, you just need the default. So that's the stub routing. Thank you very much for listening. Let's carry on now with NSSA.